So what I'm going to present today is merely, it's a work in progress on the development of an OCR workflow and tool for Greek polytonic, the multi-accent historical printed documents. And I'm going to discuss about the development of the tool and the workflow, optimization process, and quality control and post-correction. This is a brief outline of my presentation. So I'm briefly going to introduce the challenge. So then I'm going to refer to the state of the art and previous work on the area, our approach and our goal. And so then I'm going to describe you the workflow, the different steps, the data acquisition process, the OCR development, and the graphic user interface that we developed for the process, a couple of experiments during the training and the testing process, and the post-correction quality control in the end of the workflow. And then I'm going to conclude by probably referring to future steps. So although the accurate recognition of Latin machine printed text is now considered largely a solved issue, recognition of non-minority language, of non-Latin minority languages or scripts, such as Greek, having a large number of character classes is still subject of active research. And Greek polytonic multi-accent scripts have a large variety of diacritic marks, and as a result, also a large number of character classes, more than 270. So Greek polytonic documents, both handwritten but also printed ones, historical documents, cannot be successfully processed by the currently available OCR solutions. And this results to a huge amount of digitized, handwritten, but also printed Greek documents still remain without full text processing and analysis capabilities. The automated recognition of Greek printed polytonic scripts was, and I think it still is, an open challenge for all of us working in this area. It was initially introduced by Digital Classics, looking for an OCR for Greek polytonic, mainly ancient Greek, but they were having material using modern fonts. Existing tools and solutions such as DATeCH and DATeCH2019 using online recognition and character patterns, I think that they are offering limited accuracy and poor results for non-Unicode old typefaces, which is something that we have in the historical Greek documents. And the Perseus project, I think is an interesting development in the field, and it has a promising development in Greek polytonic OCR, but they're mainly using printed critical editions of ancient Greek texts. So they have specific fonts for these critical editions. In the area of computer science and machine learning, we have also interesting developments. So there is an OCR framework combining different recognition modules, such as accent recognition, recognizing characters from different text zone, or text line detection. There is another solution, or there's an upgrade of the system using also adaptive zoning features. And also there is a recent recognition system based on hidden Markov models, which is also under development. I think it's an interesting approach to observe. But so drawing expertise from document image processing, page segmentation, machine learning, and digital humanities, our goal is to develop a user-friendly OCR tool and workflow as well for Greek polytonic historical printed text. So this is a very interdisciplinary work, and our team also it's very interdisciplinary. So we have computer scientists, linguists, philologists, digital humanists. So the work is partially supported by the Cost Action Distant Reading for European Literary History. And actually, it's a byproduct of this cost action. So our goal is to create the first openly available and reusable modern Greek literary textual collection as part of the larger European literary textual collection in order to apply to this textual resource distant reading methods. So that was actually the reason for us to look for an OCR solution in order to generate this textual this corpus. So in terms of data acquisition, so we in order to train actually and to develop the OCR tool, we need to have a corpus, a textual corpus to work with. So we created a testbed for training and developing the OCR tool, a corpus of modern Greek text using polytonic scripts from historical printed documents. Our testbed combined from hundreds 19th century Greek novels. The length it may vary, so we have from 7 pages to 400 pages. And there are also project-specific criteria for the corpus sampling. So we have authors, genders, representation that we need to take into account, date of publication, and also length. The texts, actually the documents, are already digitized by various Greek institutions, such as the National Library of Greece, or also institutional libraries and projects. And we have them in PDF and JPEG formats. But because they've been produced in different stages and having different digitization standards, we also have variations in terms of quality of the end result, and also because they are mainly from original printed editions of the 19th and early 20th century, using various typefaces and diacritics. So we have also variations in the image quality and the end result. This is just an example. So you can see there is a lot of noise. We have also bad digitization, actually. So this is what we had as a starting point. Moving now to the actual OCR tool development, I'm going to briefly refer to the process, and then I'm going to show you a diagram, might be more easy for you to follow the diagram. So we had two phases actually in the tool development process. So it was there was the training and then the testing phase. The first module is to the character segmentation and recognition. So all the input document images are fed into an existing OCR tool. So we use API Find Reader as a starting point. Then we have manual post-correction and post-processing of the results in order to improve the quality of the initial character recognition and create an accurate training set to work with. Following that, we apply a feature extractor algorithm where it's already segmented character is normalized into a fixed size and then split it into 3 to 3 zones. And then from each sub-image, pixel intensity is extracted as image feature, and the final descriptor for its character is the zone feature concatenation. So this module is actually the one that is used in order to create a training set containing samples for all unique character classes. And then we move into the test phase. The same features are extracted for each new character and used as input for the classification. And for the classification, we used a machine learning algorithm, the well-known KNN, in order to classify characters to the nearest class of the train set, and based on the feature value that we have already extracted. So this is a graphical representation of our process. You can see the two phases, the training phase and the test phase. So the initial segmentation and recognition through the ABI, and then we have manual correction, feature extraction, and then the train phase, feature extraction, and the KNN classification in order to compare the two sets. So in order to assess the train phase and the manual annotation. Actually, we developed a graphical user interface that is very easy to use. It's a fast and accurate way of marking each character of a document page. Also, it's super easy to embed user feedback by complementing possible polytonic accent to a character just by clicking buttons and without really the need of typing special Unicode characters, which is very difficult to remember even for us as Greeks. So, you can edit actually very easily the end results, and then the user is able to discard or modify erroneous character segmentation and recognition results, and finally save, the all changes and the correct actually character into a database file. This is how the interface looks like. So in the one side you have the document page that you're working on, and the second is the edit panel actually. So what you can see there is like Psilida, Sia, those are the accents, and you can just click the correct one, and then you can save OCR. So those two options, edit and save, are very user-friendly and easy to use, and because this is one of the goals of our workflow, to produce an easy-to-use workflow. So a few words about the training experiments, the training phase. So we annotate 1 or 2 pages per document using this interface, and then out of this we created, we actually had 100 annotated documents pages. So in total, there were 50K character entries belonging to 143 unique classes, I think. Yes. Then we had a mass application for all the 100 novels. And then in terms of, as for the performance evaluation, we used the Liebenstein instance. And between the predicted transcription, actually, of its OCR page and the manually annotated transcription, and we resulted with an accuracy of 94.2% for the best parameter of the KNN algorithm, which was the 5. The results varied a lot, and the maximum was for example, noise-free fonts. And also we this was a 25% improvement of the system results when compared to the actual, to the initial recognition results, which was a great improvement. Couple of words for the post-correction quality control in the end. In order to further check the resulted OCR files and to produce an accurate textual corpus, we needed to manually compare and correct actually the OCR, the resulted OCR files in text form with the original digitized files, the PDFs. And in order to do so, also we created an auxiliary resource as a lookup vocabulary for the post-correction phase. This was the most laborious task for us, I must say. These corrected text files, actually, they are very useful for us because we can use them as an evaluation tool in order to evaluate the entire procedure as a ground truth, actually. And then what we're also going to do, we're going to convert them to XMLTI format using a predefined schema for the cost action. So we're going to have this fully encoded, accurate textual corpus. During the process, we collected three variables in order to document the quality control and the resources actually that we needed for this step. So we collected 3 variables: the time needed for the correction of per page, the type and the amount of error found, and this will give us an estimate of the effort and the resources needed for future, for future funding and for future use of this workflow. This is just a representation of the post-correction, actually, the results. So this is the original PDF. Here is the initial OCR text, and this is the corrected final text version. So to conclude, as I told you, this is a work in progress. This all have been done through the last year, so it's like just 1 year that we're working on this project. But while working towards the development of the OCR tool for a Greek printed polytonic script, we're also able to point out existing but somehow hidden obstacles and gaps in digitization standards and processes, ground truth, also post-corrections, workflows. And we're hoping that this new OCR framework will facilitate accessing and further processing a huge amount of historical printed polytonic documents that are currently digitized and held by cultural institutions in Greece, but with limited usability in terms of full text access or further analysis. By developing also this user-friendly and robust OCR framework, we aim also to enhance scholars to perform advanced computational processes on Greek printed polytonic textual resources. And as I mentioned earlier, for this particular phase of the tool development, we used 19th century printed text, but we're willing to enlarge the test set with earlier textual resources from the 18th century, but also kind of latest ones from the 20th century, early 20th century. From a technical point of view, we would like to think of and apply more sophisticated classification of character sets, and also we need to update on the feature extraction mechanisms. But we are open to comments and ideas, and please do get in touch. Thank you very much.
Yeah, thanks for this nice talk. Just a quick question, can you deal with segmentation errors, some also block text line word segmentation errors? Can they be corrected? What happens if there are those errors?
Yeah, I must say that I'm here representing a team, so I'm not from the technical part of the team, so I'm going to answer as much as I can. Probably Apostolos will also be keen to add. In terms of segmentation per line or per character, you mean?
Yes.
Yeah, the errors that we... Yeah, I think that they are kind of like, this is mainly manual, the segmentation correction at some point. Yeah, I think I can't contribute more.
Okay, no problem, thanks.
It's a pity that Panagiotis or Vasilis, who are the guys that I collaborated with, are not here to assist you. Sorry. But do get in touch. Just, yeah.
Thank you for the interesting presentation. I was wondering why you decided to develop your own KNN-based classifier rather than base the training on some existing open source OCR, like for example OCR Opus. I know there's been some work in Canada by Bruce Robertson, training that for polytonic Greek. Was there any specific, did you check that, or was it excluded as an option from the start?
No, I think we tested the previous algorithms and previous models that were that existed. But the thing that we had kind of we don't have such good results because we had the printed version, the fonts that they're used for this specific period of time. You know, they're not kind of like, they're more. I think that they're not very well performed somehow, you know, for this. Yeah, I think that Panagiotis told me that, you know, he tested existing algorithms, but the results are not good enough for us.
Also with training different algorithms?
I'm not sure if he trained existing algorithms. No, I can't really answer on this. Sorry.
Thank you.
Yes, your procedure very much depends, of course, on the character segmentation.
Yeah.
Do you have a statistical the correctness of that.
Yeah, we initially used ABI as a starting point, you know, for the entity segmentation and the first recognition, you know, the first layer of segmentation.
I'm just referring to segmentation because I think you always use that, the segmentation of ABI, or?
We used ABI for the initial...
So in processing, you use the ABI character segmentation?
Yeah, no, we used what ABI gave us in the first instance, and then we correct manually if there was an error. Yeah.
I mean, when you have new documents, you still run first ABI, is character segmentation, and then you classify. That's what you do, or?
I'm not sure that I'm able to answer this as well.
Completely new document, which you haven't processed yet. What do you do? I mentioned that you then first run binary, then take the segmented characters and classify them with your KNN classifier.
Yes.
Yes, okay. So you're very much dependent
On the
accuracy
yeah.
of the
On the
character
output,
segmentation.
on the result of the first
Yes,
result.
so my question was, do you have any statistics on your accuracy of that for the type of documents you're dealing with?
No, I don't have any statistics on this. Sorry.
So because your error rate really consists of
Yeah, that's
Parts
right.
the errors of the KNN classifier and the errors of the segmentation, and I would like to see a breakdown of that, where the errors come from.
Yeah, that's it. That's an interesting point. Yeah.
Thank you for your talk. It's exciting to see work going into, continued work going into digitizing ancient works and handling the special requirements and cases for the different scripts and languages over time. One thing that comes to mind is this phrase, I think Peter Norvig, a colleague at Google, and others have come up with, the unreasonable effectiveness of data. So when we think of the actual OCR recognition engine, for example, sometimes because we like machine learning, we like to think in terms of like network topologies or classical algorithms like k-nearest neighbors, etc. In my experience, I'm finding that actually the details of what the architecture is now, it may not matter so much because in a few years there'll be a new fancy deep recurrent network topology that's the next big thing. But the key ingredient seems to be, and I appreciate other people's comments on this, if there's data, training data, ideally curated or labeled training data quality that really gets at the characteristics that are specific to the time period or application or region. This is where I think the value probably is for this kind of work, and if we can really find a way to make that broadly available, then probably we can just progress much more quickly.
Yeah, if I can just notice, this was our initial goal. So we wanted to create a training set, for this specific period of Greek printed text, because it has a specific diacritics, it has specific fonts, it has even specific, if I may, kind of like characters. We might find like archigrams, in the very beginning of text. So our goal was to, and this is why we create a training phase and a test phase, because we wanted to train, and this is why we created a database. Now we have 100 documents. In the next phase, we're going to have an extra 100 from we're going to enlarge the period with different, probably fonts, with different diacritics. So that is our initial goal, to create a training set, a database of characters in order to further facilitate the process. Yeah, thank you.
Thanks for the talk. Given your talk and the previous speakers, is there any thought of a European-wide ground truth registry of some sort? And for this project, do you have any notion of using the standards or working on common standards for preserving ground truth as well as results, as this previous speaker did?
Yeah, it's the next step for us, to preserving the ground truth that we are producing for further steps, for future steps of the project. Yeah, we are willing to do that.
Last one.
want to comment on that. I was thinking the same thing. There's in different projects, different ground truths created, and I see a potential role of the central competency in here. If people mention they have ground truths, if we can link to the location of the ground truths, we don't need all to aggregate everything into the center, but we now have the ground truth collection of the impact project. We would gladly be happy to refer to, like we already do, to the Prima Self or to the website, but also to the ground truths of other projects like OCR, so that there's one central location where you can at least find the information, then see. We are trying to prepare a cost proposal with the Impact Center of Competence to create new links and networks and see how we can organize even better, bring the groups together. So I think it's a useful suggestion, and totally agree with that.
Yeah. That's very interesting. Thanks for the info. Yeah.
So I would like to, Anna Maria is representing the DATeCH2019 side of the team, as clear. So please be in touch with the technical. Some of us know the people, the other colleagues for many years. So it will be very interesting to discuss with them as well and get together and preserve the ground truth.
It's a work in progress. It's a project that we've been working a couple of years, and we need to see progress. Thank you.